Let's see the topics one by one. The first topic of this lecture is characteristics of an algorithm. We will first understand some characteristics of an algorithm. Then after this, I will give you the summary of this entire lecture so that you would be able to see all the characteristics in the same place. And then finally, I will give you the homework problem of this lecture, which you need to solve on your own after completion of this lecture. So let's start with the characteristics of an algorithm. The first characteristic of an algorithm is input. An algorithm can take 0 or more inputs. It is possible for an algorithm to receive no inputs at all, or it may receive more than one inputs. An algorithm is said to be valid in all these cases. Now let's discuss an example algorithm which takes no inputs at all. This is the algorithm. This algorithm takes no input. It generates a random number and outputs that random number. It is not receiving any input from the user. So this algorithm is an example algorithm with no inputs. Now let's discuss an example algorithm with more than one inputs, precisely 2 inputs. So here is the example algorithm. This algorithm generates the result of addition of two numbers, num1 and num2, which we receive from the user. In step number 2, we are asking the user to input the first number and we are calling it num1. In step number 3, we are asking the user to input the second number and we are calling it num2. Then we are adding num1 and num2 and finally we are outputting the result of the addition of num1 and num2. This algorithm is an example algorithm with 2 inputs. So with these 2 examples, it is clear that an algorithm can take 0 inputs or more than 1 inputs. Now as we have understood this characteristic, let's move to characteristic number 2, which is output. An algorithm must produce at least one output. It is important for an algorithm to produce at least one output. It can accept 0 inputs, but it is not possible for an algorithm to generate no output. An algorithm must generate at least one output. It can produce more than one outputs, but at least one output is mandatory. Then only we can say that the algorithm is valid. Otherwise, we consider the algorithm as invalid. Now let's see the example algorithm which produces one output. Here is the example algorithm. We are taking the same example of generating a random number algorithm. In this algorithm, we are generating a random number and we are outputting that random number. Here there is only one number that is generated. This is just one output, hence we can say that this algorithm is an example algorithm with one output. Now let's see the example algorithm with more than one outputs, precisely 2 outputs. Here is the example algorithm. In this algorithm, we are trying to generate the result of square and cube of a number. We'll receive a number from the user. This means that we just have one input. In step number 2, we are asking the user to input a number and we are calling it num. And then we are calculating the square of num. We are calling it square result. Then we are calculating the cube of num. We are calling it cube result. Finally, we are outputting square result and cube result. So this algorithm is an example algorithm with 2 outputs. It is possible for an algorithm to generate more than one outputs, but at least one output must be there. Now let's move to characteristic number 3, which is finiteness. An algorithm must terminate in finite time. If an algorithm takes forever to run, then we do not consider it as a valid algorithm. That algorithm is invalid. So, in order to say that an algorithm is valid, it must terminate in finite time. Let's discuss an example algorithm that runs forever. Here is the algorithm. In this algorithm, we are first initializing count to 0. So there is some variable count and it is initialized to 0. Then we are entering the loop. Now within this loop, we are incrementing the count by 1. And we want to repeat these steps 3 and 4. This is what is given here in step number 5. Repeat steps 3 and 4. but we are not specifying when to stop this repetition. We are just mentioning this that we need to repeat these steps, but we are not mentioning when to stop. So this algorithm will run forever. We will continue to enter the loop, but there is no termination criteria. So this algorithm will run forever. Now let's discuss an example algorithm which will terminate in finite time. So here is the example algorithm. We are first initializing count to 0. Then we are setting a limit for the number of counts and we are calling it, let's say, 10. So we are setting this limit of 10. Then we enter the loop that iterates up to the specified limit. Now within the loop, we are incrementing the count by 1. And in step number 6, we are clearly specifying this that we need to repeat steps 4 and 5 until the specified limit is reached. What was the limit? The limit was 10. So we will repeat these steps 10 times. And this means that the algorithm will terminate in finite time. It will not run forever. So this algorithm is considered valid, while this algorithm on the other hand is invalid. So an algorithm must follow the finiteness characteristic, that is, an algorithm must terminate in finite time. Now, let's understand the characteristic number 4, which is definiteness. An algorithm must be clear and unambiguous. It is important for an algorithm to not have any ambiguity. Now, what does this mean? This means that each and every instruction or step of an algorithm must be clear and precise, or we can say that they must give only one meaning. There must not be multiple meanings of these steps we are writing. So an algorithm must be clear in its meaning and it must be unambiguous. This means it must not have any ambiguity. There must not be multiple meanings of the steps that we write for an algorithm. Now let's see the example algorithm, which is ambiguous. That means algorithm with ambiguity. Here is the algorithm. In step number 2, we are asking for two numbers a and b, and then as mentioned in step number 3, we need to perform some operation on a and b. Here we are not clearly specifying which operation. We are just specifying some operation, which is not clear and it is ambiguous. After this, we are outputting the result. But the main thing is, we are not specifying which operation to perform here. Hence, this algorithm is considered ambiguous. On the other hand, let's discuss an example of algorithm which does not have any ambiguity. So here is the example algorithm. Here we are asking for two numbers a and b, and then we are calculating the sum of a and b, and we are storing it in the variable sum. After this, we are outputting the result of the sum. Here we are clearly specifying in step number 3 that we want to calculate the sum of a and b. Not just some operation, but sum. So this algorithm is an example algorithm which does not have any ambiguity. We are clearly specifying each step and each step has only one meaning. So with this, I hope it is clear what is the meaning of definiteness. An algorithm must be clear and unambiguous. Let's now understand characteristic number 5, which is effectiveness. An algorithm should take less time and space to execute. It should run in less time and it should take less memory space as well. We will learn throughout this entire course how to design algorithms in the way that should take less time and less memory space. Time is a very important resource and so is the memory space. We'll try to preserve them as much as possible. We will see several tools which helps us in analyzing an algorithm that tells us how effective an algorithm is. Now let's discuss an example algorithm which is less effective. This means which takes more time. Here is the example algorithm. Through this algorithm, we want to calculate the sum of first n natural numbers. For this purpose, we first ask a positive integer n. We want to calculate the sum of first n natural numbers. That is why we are asking for a positive integer n. Then we are initializing the variable sum to 0. After this, we are entering the loop that iterates from 1 to n, and inside this loop, we want to add the current iteration value to sum. We want to repeat steps 4 and 5 here. These steps will be repeated until we reach value n. Finally, we will output the value of sum. You can verify this on your own that this algorithm has the capability to produce the result of sum of first n natural numbers. That depends upon the value of n. It can be 5, it can be 10. Try to take one example value of n and try to run this algorithm on your own and understand this how we are getting the sum of first n natural numbers. The time complexity of this algorithm is big O of n. We will learn more about time complexity, but just keep this in mind that this algorithm will take big O of n time. Now let's see the example algorithm which is more effective. Here is the example algorithm. With this algorithm also, we want to calculate the sum of first n natural numbers, but this time we are using this formula, sum equal to n into n plus 1 divided by 2. We are well familiar with this formula to calculate sum of first n natural numbers. This algorithm is more effective than this algorithm because the time complexity of this algorithm is big O of 1. This algorithm is much faster if we compare it with this algorithm. Now you might be wondering, what is the meaning of time complexity? Don't worry, we will understand time complexity in our subsequent lectures because this course is all about the design and analysis of algorithms. In the analysis part, we will understand how to analyze an algorithm. This means to check how effective an algorithm is. Just remember for now that big O of n is bigger than big O of 1. This means that this algorithm takes more time compared to this algorithm. This algorithm is much faster because here we are using this formula to calculate the sum of first n natural numbers. And here we are using loops. We will understand this why it affects the time complexity in our subsequent lectures. For now, just remember this that big O of n is bigger than big O of 1. Hence, the time complexity of this algorithm is greater than that of this algorithm. This algorithm takes more time compared to this algorithm. So this is all we need to understand about the effectiveness. An algorithm should take less time and space to execute. Our clear preference is this algorithm because this algorithm takes less time. So with this, we have understood all the characteristics of an algorithm. Now let's see the entire summary of this lecture. This means all the characteristics in one place. So here is the entire summary. First characteristic is 0 or more input. This means an algorithm can accept 0 inputs or maybe more than 1 inputs. But it must generate at least one output. An algorithm must take finite amount of time and it must be unambiguous. Also, an algorithm should be effective. This means we must always target to write algorithms which take less time and space. So these are all the characteristics of an algorithm which we need to keep in our minds. Now, let's move to the homework problem of this lecture. Here is the homework problem. Determine what characteristic or characteristics are missing in the following algorithm. Here is the algorithm. You need to determine what characteristic or characteristics are missing in this algorithm. It might be possible that in this algorithm more than one characteristics are missing. You need to identify this on your own. Try solving this question and post your answers in the comment section. So with this, we are done with this lecture. Okay friends, this is it for now. Thank you for watching this presentation. I will see you in the next one.